Great. So yeah, I'm Steve Manuel. I'm here to talk about Extism, your framework to build with WebAssembly everywhere. So I'm a co-founder and CEO of a company called Dilibso. We focus exclusively on WebAssembly and building better tools for better developer experiences. One of those tools is called Extism. We also build things for observability and debugging, runtimes, and some other cool things that hopefully you'll all see pretty soon. I love open source software. I've been working in open source for longer than I care to admit. Before Dilibso, I was working on compilers for quantum computers, and before that was doing Rust on Cloudflare workers. It is true, I get lost easily, so if you see me wandering around Barcelona, please help me. Extism, I'll give a quick introduction, be a little show of hands. Does anybody know of Extism or heard it or possibly used it? Right on, all right, cool. Well, then I'll be fast here. I like to say that's the easiest way to embed WASM inside of your applications in pretty much any language that you want. So we've done kind of the painstaking work of making it easy to create the bindings, do the installations, and run WebAssembly in now 16 different languages. And we designed Extism to really be the first off-the-shelf plugin system. So you want to run untrusted code from users inside of your applications. That's what Extism is great at, but we also see a lot of people building other things with it, like functions as a service platforms, any kind of like universal libraries for distributing some code from one language and bringing it into another. So we're really excited to see what people are building with it. And at a lower level, Extism is just a universal ABI, and it does guest host interaction between those 16 languages and these 8 that you see here. And actually, .NET counts as 2 because it's both C# and F#. Extism is this ABI that's implemented identically over many different popular runtimes. And you can see all the places that run WASM very well, including WASM-time, V8, JSC, SpiderMonkey in the browsers, our own Java native runtime called Chicory, and Wazero, a Go native runtime. Over the last year and change, about 13, 14 months, Extism has grown a lot on GitHub. We've had a lot of developer love, which we really appreciate. Thank you all. We've had up to 3,600 stars as of today-ish, and around 30 or so contributors. So incredible stuff. Please keep working with us on the project. We really appreciate your help. We launched in December of 2022. The project was announced, and we then announced our version 1 just recently in January of this year. There is a QR code here to the blog post that talked about all the things that had to kind of come together and places that Extism can go in our V1 announcement. I'm going to talk a lot about that anyways today, so I might be able to save you a few minutes of a blog post. So what is Extism V1? What's in here? What are we committed to? Why did we put all this work into this framework? Extism makes it very easy to load WASM modules with those modules compiled with our PDKs to do kind of easier I/O and guest host interactions. You can easily call those function exports from your module. So if you've seen tutorials about WebAssembly and they basically lead you to do add of 2 integers, things that go beyond adding 2 integers start to get kind of complicated kind of quickly. And our goal was to make that kind of next step easier for new developers to kind of get into Extism. So passing complex data, calling functions beyond start in WASI and things like that are really easy in Extism. It's also a set of capabilities available through imports or host functions that are identical across those runtime environments. So complex things like making an HTTP callout from WASM, we make pretty easy. And that Extism runs across pretty much any environment you want: browser, servers, desktop, IoT, mobile, databases, everywhere. If your module can be compiled with an Extism PDK, it's going to run in any Extism host, and those run the gamut of pretty much anywhere compute can run. And we also ship this thing we call the Extism kernel, which is a subset of the Extism capabilities that are compiled to WASM. And this makes it really easy to implement on more runtimes. So we make it very easy to do memory allocation, I/O, error handling, function calling. All this stuff is actually implemented in WASM, so it's easier to kind of port to different runtimes. Sometimes I like to think it's easy to look at other things we're more familiar with to try to kind of get a frame of reference of like, what is Extism, how does it fit And so this is a matrix that kind of lists some things that we all may be familiar with otherwise. On the left-hand side, we've got different columns or rows of scenarios. So like I want to work with WASM, or I want to build a microservice, or I want to orchestrate some processes. We'll start from the bottom and go up. The columns say, well, on the far left, you're on your own. If you're just running a WASM module, calling it in a WebAssembly API in the browser, it's entirely up to you. You're instantiating the module, you're passing it host functions, you're calling the functions you need. And C, you're certainly on your own, linking your own libraries. And if you want to orchestrate processes, you might be just running and spawning processes on an operating system like Linux, Mac, or Windows. Moving to the right, the next is kind of this single language or platform abstraction. And so, for example, with WebAssembly, if you've ever used Wasm bindgen, that's a great tool as long as you want to run interop with JavaScript. And if you want to write code in Rust, that tool makes it really nice. So that's just like a little bit of additional help. So maybe for building a microservice, you make the jump from C to Python, and now I've got a single language to work with, and that's awesome. And then, like, if you're orchestrating processes, moving up the abstraction ladder, you might use LXC to do Linux containers on a Linux operating system. So single platform. But now we want to get a little bit more advanced. We want to go to multiple platforms. You need a little bit more help from additional framework. That's really where Extism comes in. Very helpful to kind of get WASM into more languages or run more languages in WASM. Kind of like how Flask helps you do things easier on top of Python, and similarly Docker gives you this abstraction over different platforms to run containers. And then finally, all the way to the right, the highest level of abstraction to kind of take full control of everything, make the decisions for me. The component model might handle that for you in WebAssembly, just like gRPC may do the same for building a microservice, and that Kubernetes will do if you are orchestrating processes. So hopefully that kind of gives you a frame of reference of like how much abstraction we're giving, where we're focusing, how we're trying to help. So why do we need Extism? It feels like WebAssembly's mature, like we can run it. We know how to compile languages to WASM. We've got awesome runtimes. I like to use jQuery as an analog here. If folks remember writing code that used jQuery, or before you had jQuery in the browser, if you were doing things with animations or trying to make networking work and calling out to APIs, you probably reached for something like XML HTTP request or ActiveX object. Sorry if I'm invoking fear or pain from the past. But the point is that there were all these different APIs on different browsers, and they weren't consistently implemented. And it was difficult to ship code for those platforms. You had to handle special cases, and code worked differently on Safari than it did on Firefox than it did on Internet Explorer. And jQuery came along and it said, well, let's actually just abstract those backends away, where a backend is a browser and its specific set of APIs. So jQuery presented this lovely kind of universal, uniform API to JavaScript developers to program against. So for example, if I wanted to send a post request with jQuery, I could just use jQuery's global, call its post function, pass it a URL and some configuration data, and that was it. And behind the scenes, jQuery would say, I detect you're on IE. We're going to use ActiveX object. I detect you're on Safari. We're going to use whatever was the built-in function at the time. And then it would handle polyfills for you. It would do all these kinds of things. The point is that it would spread those inconsistencies out and make a more universal, uniform experience for developers who wanted to build JavaScript applications. Extism is kind of the same. It gives you this universal abstraction, but instead of for JavaScript, it's for all of WebAssembly. And so much like how jQuery presented this easier, straightforward interface for executing code, Extism has provided with this pseudocode listed here. I'll show a lot more real code later, but a more straightforward interface. I can create a plugin by loading WebAssembly code and giving it some capabilities. And once I have that plugin, I have one method on it, call. Call a function for me by name and pass it in some complex data and get some data out as output. And so Extism then sits as a layer on top of all of these runtimes. And so the same Extism APIs are implemented for all of the runtimes, and we'll pick the best runtime for you. If you're in a Go environment, we're going to bring WAS0 for you. If you're in a JavaScript environment, we're going to bring one of the native WebAssembly W3C APIs. And if you're in Rust, and then pretty much anything else, we're going to bring you Wasm time. The exclusion of that is that we have also a Java runtime, and if you're in a Java application, Chicory might be the best option for you. But don't take my word for any of this. This talk is chock full of demos, and so I'm going to take us on a journey across GitHub to just walk through like a bunch of different ways to run the same WebAssembly code in a ton of different languages. So if you'll join me, I'm going to switch gears here. Before we jump into the demos, I want to show a little bit about the code that we're going to run. It's hosted on this service we actually provide called ModSurfer. And ModSurfer does a cool set of extractions from the module, and we'll show you actually what you're working with. So you can see here some of these Extism imports are the host functions that we provide that give Extism its kind of superpowers and make it easy to do memory management and I/O and things like that. And then at the bottom, we've got the exports. And these are the functions that I'm going to call in the plugin, in the Wasm code, throughout the variety of languages of host environments that I'm going to call this Wasm from. So this particular module is a converter that takes text, a string, and turns it into a PNG. And one of the cool things about this module that's unique to Wasm, and maybe not so unique to other languages, but it doesn't have any native dependencies. I don't have like bindings to Cairo or Node Canvas or anything like that, which really simplifies a build process for an application that might have to generate bindings and link some native code as that application is created. So the first one is in the browser. I think we're all pretty familiar with the story of WebAssembly on the web, but this particular application just hosts a web page, has two HTML elements, input to type some text, and then an image tag to handle the output of the Extism plugin, which is going to take that text and convert it to an image. And I just need to click a link, and we're here. It's loading some Wasm. It's going to load up, and let's see. Hello, Wasm.io. As I typed, every single keystroke called the Wasm function to regenerate a new image and plop it into the DOM. I don't know any other way to prove to you this is an image besides just holding and clicking and dragging it around, but it sure is a PNG. So yeah, demo 1, we did it. That was the browser. Now, a similar environment to the browser is Cloudflare Workers, but there are a lot of differences in the way that Cloudflare loads Wasm code and calls functions in it. So this is the same JavaScript SDK that was loaded in the browser, but used inside of a Cloudflare Worker environment. You'll notice that Cloudflare has to load the Wasm code ahead of time before you actually execute the function. But the code all looks very similar. I get some input, I create a little JSON blob from it, just declaring the text that I want to convert, maybe a color for the image and the font size to use. I call image in the plugin, I get bytes back, and I spit that out in the response. And pretty snappy, thank you, Cloudflare. Here we go, there's the image from the input, and I can go ahead and even change, whoops, typed the wrong thing, same thing. Oh my God. There we go. Caching. What's next? Anybody do any C++? Ever try to load Wasm inside of a C++ app? Not the easiest thing. Extism says otherwise. We've got the same function here, plugin call, calls the image function, takes some input to configure what the image should look like. This is a TCP server that handles the HTTP line and processes that line, calls the function when it gets a request in, and there we go. We've got a Python example. Python's pretty nice. I didn't grow up writing Python, but this demo has me tempted to write more. All that code condensed down into 12 lines. This Python program exports this endpoint, and the parameters to this thing, read root, are auto-converted into serialized query parameters. So there's a lot of magic behind the scenes here. In this case, we do the same thing. We call our plugin. It's constructed from our WASM loaded from that URL, and we pass it this JSON object with the text, the color, and the font size. And there we go. Let's see. Perl's a fun one. Anybody write any Perl still? I know you do. You made this demo. OK. Yeah, same idea, right? So we're able to load a plugin using a very familiar interface, pass in some JSON-like parameters to it, call the function, and get our image. This is the same exact WASM being called in all of these environments. One other one that's interesting to look at is on a serverless platform like Vercel. Pretty easy to load some WASM in. This is using their Go runtime. Call the same Extism plugin, pass it the data from the input, call the function, and come on, Vercel. Return our result. There we go. And let's see. We've got my favorite is Zig. Anybody else like Zig in here? Nice. So there's a pretty cool new HTTP framework in Zig called Tokamak, and it runs Extism really nicely. So the same idea. Create a plugin from some WASM, pass it some data, and get back our image. I'm going to do two more here that I think are maybe some of the more exciting ones. WordPress. And I hope I'm still logged in here because I've actually forgotten the password. But if I'm not, we'll skip through it. I'll show you the code, you'll get the point. This is actually running inside of a WordPress plugin. So we're nesting plugins now, everybody. So WordPress has this amazing, huge, rich ecosystem of plugins. Now we can bring WASM to it, and that's pretty neat. You can see here the title gets rendered as the image there. And then lastly, I think this is maybe my personal favorite, is a lock screen. Do we have any accountants in the house by chance? Finance people? Probably not. Well, to not make it so boring, this is Excel. These are x86 instructions on the left-hand side. And I'm going to use another Extism module here because you can't really render images, at least that I know of, inside Excel. And we're going to run our count vowels module. And you can see here that this is actually a Excel function that is wrapping a Extism plugin running inside of Excel, which is pretty cool, I gotta say. So we can bring a whole bunch of new code to an environment that hasn't seen a lot of new code in quite a while. Anyways, so why are we doing all this? What's the point? Like, we know we can run WASM. We want a consistent and uniform interface to help developers bootstrap projects and run lots of code in lots of different places. And with Extism, we can have the end-all last plugin system that we ever need, and to get a mature ecosystem of plugins that can move from a WordPress application to a Laravel app, or from a Ruby application to a Go one. There's lots of opportunities to share code and bring it across different places. So I'm really excited about Extism, how far we've come, launching our 1.0, and thank you all very, very much for walking through the demos with me today. I don't hear any music or hear Sergey, but if anybody has any questions, I'm here or available after the talk.
Hi, thanks for the presentation. Happy user of Extism, but I have some concern about the browser side. Currently, when I'm using Extism, the Wasm file is a bit big for me on the browser side. Is there some plan to make it lighter?
It's entirely dependent on which language you're coming from. The Extism PDK will add a tiny bit of overhead, but really it's in the order of a kilobyte or so at most. And so it depends on what you're packing into the module. Can you share more about the language you're using?
It's Rust, primarily. I don't use the PDK. We are creating the Wasm. But in comparison, using it then with Wasm Bindgen, for example, we get like 25% bigger with Extism. It's a small size, but it's important for us on the client-side perspective.
Yeah. I mean, all of the usual tricks I'm sure you've tried.
Wasm,
with release,
the same Wasm
opt.
optimization than with Wasm Bindgen, exactly.
Yeah. You can compile, it depends on what you're doing in the Rust code, but you can compile it with a no-std attribute if you're not using standard library things. That gets most of the size away, but you might need some of that stuff in your app. I'm happy to try to go over a couple options, but I mean, at the end of the day, it's just the code you're compiling is the code that ends up in the Wasm module, so I don't know. Thank you, though. Right on. Well, thank you, everybody. Good to see you all. Enjoy the rest of the conference.